Well, hey tech fans, happy holidays and welcome back to Mackey Tech. Today we are checking out the SpacemIT Muse Pi Pro, a Risc-v based single board computer aimed at developers, makers, and anyone curious about this new open architecture platform. SpacemIT sent me this board at no charge and no money has changed hands. SpacemIT has not seen this video before it's uploaded, and as always, everything mentioned here is going to be my honest take. SpacemIT is a China-based semiconductor company focused on building high-performance Risc-v CPUs and a complete ecosystem around them, especially for AI, edge computing, and developer platforms. Their goal is to make Risc-v practical beyond research and into real usable hardware. Their product lineup includes boards like the Muse Pi and the more fully featured Muse Pi Pro, which we're reviewing today, which are single board computers aimed at developers, early adopters, as well as their Muse Book, a Risc-v powered laptop running their custom Bianbu OS. And if I say Bianbu, or whatnot, you'll hear that the whole video. It's kind of hard to pronounce. Together, these products are all about pushing open architecture Risc-v hardware into everyday Linux and AI workflows. The Muse Pi Pro is based on SpacemIT's first-gen K1 platform. The actual system-on-a-chip is the SpacemIT M1, an 8-core 64-bit Risc-v chip rated for up to 2 TOPS of integrated AI acceleration. SpacemIT says the next generation will move to a K3 successor, targeting the next Muse Pi Pro in the first half of 2026. The Muse Pi Pro features a full-size HDMI port, USB-C for power, 4 USB 3.0 Type A ports, an M2 slot for NVMe storage, and a mini PCIe connector for add-on Wi-Fi cards or 4G, 5G cellular modems. It also has onboard Wi-Fi 6, Bluetooth 5.0, a 3.5mm audio jack, onboard EMMC storage, a micro SD card slot, one MIPI CSI interface for connecting cameras, and another slot for DSP interface for displays, as well as a gigabit Ethernet port. On top of the board, you'll also find 3 side buttons for hardware reset, power on and off, and firmware flashing. My unit has 128 gigabytes of onboard eMMC storage and 16 gigabytes of RAM, but the board is also available in 64 gigabyte storage and 8 gigabytes of RAM respectively. The Muse Pi Pro is available for purchase on AliExpress and BPI Shop for between $140 and $200 depending on the eMMC storage and RAM configuration. Included in the box, we have the board, which was shipped to me with acrylic supports and fan attached. We also have a USB breakout cable, additional standoffs, quick reference manual, Wi-Fi antennas, and a 30-watt power supply. Now, I wanted to touch upon CPU architecture a little bit because, as we'll see, architecture for this board really does matter. When we say something is RISC-based, we're talking about the design philosophy. CPUs like the ARM processor used in smartphones, Apple Silicon, and the Raspberry Pi use simpler instructions, but they just do a lot of them super efficiently, which is why you see them everywhere. On the other side, the CISC-based CPUs like the x86 from Intel and AMD use more complex instructions that can do more in a single step. That's great for compatibility and raw desktop performance and gaming, but it usually comes at a cost of power efficiency. And that brings us to Risc-v, which is a specific RISC instruction set, and the big difference is that it's open source and royalty-free. All Risc-v chips are RISC, but not all RISC chips are Risc-v. And that brings us back to this board. The Muse Pi Pro is built around the SpacemIT's M1 Risc-v SoC using their K1 CPUs, as we mentioned, which include vector and AI extensions baked directly into the CPU. SpacemIT's AI acceleration architecture is called Douye. And yes, I'm sure I probably butchered that, so get used to it. But roughly translated, it means unified path. It basically means there's no separate AI chip or NPU chip. All the AI acceleration is handled directly by the CPU using custom-built Risc-v instructions. So when you're running things like ONNX AI models on the Muse Pi Pro, you're not really testing a GPU or NPU, you're testing how well the CPU itself can handle AI inference, which we'll talk about and dig into later in this video. So now that we've covered the hardware and what's powering this board, a quick note on the documentation on their website before we jump into the OS. There's a site for the Bianbu OS and a separate developer site which includes the Muse Pi board specifically, as well as their documentation. So unfortunately, on many occasions the developer site and said documentation links simply didn't load for me, so it didn't feel super cohesive. There's not a clear home page or landing page on either portal, so I found myself getting lost a lot between sections, and I didn't even notice the Muse Pi Pro Quick Starts guide, the one with the micro SD card boot steps, until after I had concluded my testing. So I really didn't have time to properly try the other compatible images they list, like Fedora, Ubuntu, or OpenHarmony on the Muse Pi Pro. So with that out of the way, let's take a look at the OS Bianbu, which is Debian based, which is version 13 Trixie, and built by SpacemiT specifically for their Risc-v hardware. Under the hood, it uses GNOME for the user experience layer, but it also pulls a lot of lightweight components from the LXQt ecosystem. Bianbu Star is SpacemiT's customized overlay for the OS with its own theme and default apps, kind of like how Ubuntu customizes GNOME, but with a heavier focus on lightweight LXQt based tools. When you first boot up the Muse Pi Pro, setup is really straightforward. You create a user, pick your region, your keyboard layout, connect to Wi-Fi, and that's basically it. I did a quick system update and was up and running in just a few minutes. One thing you'll notice pretty quickly is that Bianbu doesn't have a traditional software store, and the system settings are pretty minimal compared to something like Ubuntu or Fedora. At first that might seem a little bare bones, but I'm pretty sure it's intentional so the OS runs more efficiently. Bianbu feels much more like a developer desktop than a consumer-based one, which explains why the settings are trimmed down to just the bare essentials. Out of the box though, you still get LibreOffice, a Chromium web browser, and a solid set of lightweight apps, and this is where you really start to see the influence of the LXQt ecosystem. Bianbu borrows very heavily from the LXQt, using apps like PCMan FM-Qt as the file manager, LXImageQt for image viewing, and File Archiver, as well as other settings modules. The file manager in particular stood out to me. It's fast, clean, and very responsive, similar to the desktop experience. Windows open quickly, animations are smooth, and everything feels very fluid. For a Risc-v system, that's actually pretty impressive, and I think leaning on the lightweight LXQt components is a big reason why. Bianbu isn't trying to be flashy. It's just a fast, clean, developer-focused desktop that I ended up really enjoying more than I expected. So with the OS experience covered, let's get into some testing. For the first test, I ran a 5-minute Sysbench benchmark calculating prime numbers up to 20,000. This is a straight-up CPU test, no AI acceleration, no vector tricks, just raw compute power. And the Muse Pi Pro came in at about 327 events per second. Now, for some quick context, the Raspberry Pi 5 usually runs anywhere from between 1,200 and 1,400 events per second in the same test, and that's expected because the Raspberry Pi 5 is going to be more efficient in this specific test. And the reason why is the Pi 5 is running much higher clock speeds. The ARM cores, like the Cortex A76, have had years of tuning for this type of general purpose workload, which is what the Pi 5 is better at and built for. What impressed me, though, is how cool the Muse Pi CPUs ran during the Sysbench test. With the active fan running, the CPU temps never went above 25 degrees C, and the power draw stayed between 3.8 and 4.3 watts the whole time. It just ran very, very quietly and very, very efficiently. So in pure CPU benchmarks like this, yeah, the Raspberry Pi 5 is clearly the winner, but this isn't really the workload the Muse Pi Pro is aiming for. Things will start to get very interesting when we move away from the raw CPU tests and start looking at AI Inference, which is where this board is really designed to shine. For the AI Inference, I'm using what's called ONNX Runtime, and ONNX is basically a portable format for testing AI models. And what we're doing here is what's called AI Inference, as we mentioned, but it's not training. Inference just means like, here's an image, how fast can the system figure out what it's looking at based on the models it has. In this case, I'm running a lightweight ResNet 50 image classification model. The script basically feeds in an image, first to Kitten, and measures how long it takes to identify it. With AI extensions enabled via what's called their execution provider, the Muse Pi Pro identifies the Kitten as tabby in about 90 milliseconds. When I switch the provider to CPU only, basically turning off the AI acceleration, the time jumps to over 600 milliseconds. Same model, same image, just without AI instructions. And just for kicks, I tested it with a photo of myself wearing a black t-shirt with AI acceleration turned on, and it correctly classified it as a jersey or a jersey t-shirt in about 94 milliseconds. And just to be clear, the model isn't wrong for not saying man with glasses or baldy. It can only choose from the AI models it was trained on, like tabby or jersey or t-shirt. This test isn't about intelligence or accuracy. It's about how fast inference runs on the hardware. And that's really the point of the Muse Pi Pro board. As we mentioned, there's no separate GPU or NPU. AI acceleration is baked directly into the CPU using the custom Risc-v instructions, and ONNX lets us clearly see the difference when we turn these models on and off. So I really found the Muse Pi Pro a lot of fun to play with and to test, and it ran a lot better than I expected. The Bianbu Star OS desktop is fast, stable, and feels very developer first, but it's not flashy, but just polished enough that you can actually get stuff done. And so that brings us to who this board might be best suited for. The Muse Pi Pro is not designed to be a Raspberry Pi replacement or a daily driver for the general consumer. However, if you're a developer, maker, or early adopter who wants a practical Risc-v Linux platform for edge AI products, this is a very strong option, and the $150 to $200 price point definitely offers a lot of value. So that is going to wrap up this video, tech fans. If you found it helpful, please make sure you click the subscribe button, give the video a thumbs up, and drop us a comment with your thoughts. If you'd like to support me, please consider stopping over at my Patreon, where I have tons of behind-the-scenes footage, including the unboxing of the Muse Pi Pro, which is stellar, as well as in-depth tutorials from a lot of my YouTube videos. A special shout out to SpacemiT for sending me the Muse Pi Pro for testing. I will be leaving purchasing links in the video description. A special thank you to all of my Patreon supporters, you know who you are. And of course, thank you all for watching. We'll be talking to you again very soon.